Welcome to this video tutorial over introductory polar coordinates. We're going to look at a total of 4 problems. The first two on the screen are in rectangular coordinates currently, and we want to convert them into polar coordinates. Whereas the next two items we will look at will already be in polar, and we will try to get them into rectangular. So first and foremost, it's helpful to draw a picture. In this first problem, this point is going to be in quadrant number 4, so let's draw the graph accordingly. If it's in quadrant number 4, we have that the x coordinate's positive 10 radical 2, the y coordinate's negative 10 radical 2, and we could simply draw in our triangle from there. We'll draw it like so. It doesn't necessarily matter whether you draw the triangle up against the x-axis or up against the y-axis, so I might alternate how I draw it. We know that this part here is 10 radical 2. We know that this part over here is 10 radical 2. And hopefully we realize that this would be a special right triangle. It's the 45, 45, 90 isosceles right triangle. Multiply the leg by radical 2 to get the hypotenuse. We know the hypotenuse is 20, and this is going to be a 45-degree angle right there. Hence, in polar coordinates, this point would become 20 because that's its distance from the origin. It's the radius, so to speak. Comma, we could write this as negative pi over 4. So there is one expression for a polar coordinate of the given point. However, it could have other representations. You could also call this 20 comma 7 pi over 4. That would be in the same spot. We can even use a negative radius. Now a negative radius would mean that we're going in this direction for the angle, but backwards because of the radius. So we could say negative 20 comma 3 pi over 4, and that would give us the same point. More than likely, on average, I would just be looking for one way to represent the given point. Let's go to this next point. Negative 11 radical 3 comma 11. That means it's going to go left further than it's going to go up in this case. So negative 11 radical 3 comma 11 would be over here. We could draw it in. More likely than not, I will be giving points that are formed by special angles on our unit circle. So this is 11, this is 11 radical 3. This would be our short leg, this is our long leg in a 30, 60, 90 right triangle. So double the short leg gets us the hypotenuse. This would become 22 is its distance from the origin, or its radius. For the angle, this angle here, and hopefully we're all good with the radian measures, this should be 5 pi over 6, which is 150 degrees. So here's how we could represent that given point in polar coordinates. There would be other ways we could express it as well. For one, we could say negative 22 in the direction that I'm drawing on the graph in orange. That direction was negative pi over 6, or we could have even said negative 22 comma 11 pi over 6. Any of those would be acceptable. Let's move on to looking how to convert from polar into rectangular. So for this point on the left, we would be drawing in an angle at 3 pi over 4, and this is telling us we go 3 in that direction. Now if we were to draw in the triangle itself, this is going to be an isosceles right triangle, so we'll divide by radical 2, and we would get 3 radical 2 over 2, 3 radical 2 over 2. So when putting it into rectangular coordinates, it goes to the left 3 radical 2 over 2, and it goes up 3 radical 2 over 2. Hence, there is our point in rectangular coordinates. Similar deal for this next problem. We're going to go to an angle of 11 pi over 6. Here's 11 pi over 6. But we want to go negative 8 in that direction. Since we want to go negative 8 in that direction, that means go backwards 8. So we're going to backtrack and we're going to go back 8. This is going to give us our triangle where we have a 30, we have a 60, we have a 90, because 11 pi over 6 yields a 30, 60, 90 triangle. Half of the hypotenuse is the short leg, multiply by radical 3 to get the long leg. We're going to the left 4 radical 3, and we're going up 4. Now there's only one way to represent a point in rectangular coordinates, so it's not as if we have multiple options. Last but not least, remember the other way we said you could do this is that x is always equal to r times the cosine of theta, and y is always equal to r times the sine of theta. So in this problem we could have taken a negative 8 times the cosine of 11 pi over 6. Cosine of 11 pi over 6 is radical 3 over 2. Negative 8 times radical 3 over 2 would be a negative 4 radical 3. And here we would take negative 8 times the sine of 11 pi over 6. Sine of 11 pi over 6 is negative 1 half. Negative 8 times a negative 1 half would have been a positive 4. Once we get really comfortable with these types of conversions, my guess is the picture would be the faster approach. So that's why it's good to kind of understand the picture as we proceed through polar coordinates.